g of x equals x natural log of x. Now you cannot split that into x plus the natural log of x. You can only do that when there's something multiplied after the natural log. So unfortunately, because we have two different functions multiplied together, we're going to have to use the product rule on this. So we're going to let the first be x and the second be natural log of x. And then we'll find the d first and the d second. So what's the derivative of the first? 1. And what's the derivative of the second? 1 over x. Yeah, it's the derivative of what's after the log divided by what's after the log. So 1 over x. And then we just put it together. We have first d second plus second d first. So first d second plus second d first. So 1 times the natural log of x. And if we clean that up, we get 1 plus the natural log of x. So when you're using the product and quotient rule, sometimes you will have natural logs left in your answers. So you have to be really careful and stop and think about it. Any questions about that? You're comfortable with that? Okay, take a look at the difference in these. The first one says y equals parentheses natural log of x to the fourth, and the other just says y equals natural log of x to the fourth. The first one means natural log of x times natural log of x times natural log of x times natural log of x. But then we have to do the product rule on like 4 things. We don't want to extend it out that way. If that were just any parentheses to a power, how do we take the derivative of a parentheses to a power?
Chain rule.
Chain rules. We have to do the chain rule on that one. So we do power times coefficient, down 1 on the power, times what? The derivative of the inside. Well, what is the derivative of natural log of x?
1 over x.
And then you just clean it up. So we have 4 natural log of x all to the 3rd power all over x. And no, you can't cancel those x's. One's hooked onto a natural log and one is not. And one's in parentheses and one is not.
I'll still try.
I'm sure you will. So. Let's look at the second one. If I want to take the derivative of y equals natural log of x to the 4th, that doesn't have any parentheses. So I simply do the derivative of what's after the log, which is 4x cubed, right? Over what's after the log, which is x to the 4th, and that will simplify to 4 over x. That's one way we could work that problem. Another way you could work that problem is remember that the first thing we could have done is we could have applied the power property and brought that 4 to the front since it was hooked just to the x. So it could be 4 natural log of x. And then to take that derivative, you simply keep the coefficient and multiply by the derivative of this, which is 1 over x. So you would get the same thing. See the difference though? And this is a lot more complicated of an answer than this one. So be careful when the natural log is in parentheses. The entire thing is probably going to have more steps than you think. So for this problem, we don't have any natural logs. I just want to look at it to make sure that we don't try to treat a problem that doesn't have a natural log like it does. So for this one, I first have to write it in exponential form. And then just take the derivative from there using the chain rule. 1/2 down 1 on the power times the derivative of the inside, which is an understood 1. And so really that becomes 1 over 2 square roots of x plus 1. What I have found is that people are really loud in the bathroom, number 1. And number 2, that once we start doing natural logs, y'all start trying to apply that formula to all kinds of weird things. So avoid that temptation. You only do the derivative over itself if it has a natural log with it. Make sense? Okay. Well then, I think we're ready for this guy. It says h of x is equal to the natural log of x multiplied by x squared plus 1 squared, all divided by the square root of 2x cubed minus 1. Well, I don't know about you guys, but I'm not really interested in taking the derivative right now, because if I do, I have to do the derivative of all of that stuff after the log, which would involve a product rule inside of a quotient rule, and probably a little bit of chain rule to go in with it. And then I would have to divide by what's after the log, which would require you to divide by a fraction, which probably scares you more than the product rule and the chain rule and the quotient rule. So this is one of those instances where it's probably in your best interest to split it into separate logs, to expand it out before you start. So that's what we're going to do. Before we start trying to take the derivative, we're going to expand it into the natural log of x plus 2 natural log of x squared plus 1 minus, what is that denominator going to become? I take that square root and make it to the 1/2 power, right? So could that become minus 1/2 the natural log of 2x cubed minus 1? Now I expanded it in one big step. You could have taken that in 2 different steps, expanded it into 3 logs and then applied the power property. Does it bother anyone that I went ahead and applied the power property as I went? We're okay with that? Yes? It's back in college algebra that made everybody upset. We're okay? All right. Once you get there, you just take the derivative of each term separately. So h prime of x is equal to the derivative of this piece is what? 1 over x plus, and for this next piece, you simply keep the coefficient. So it's going to be plus 2 times the derivative of x squared plus 1, which is all over x squared plus 1, minus 1/2 times what?
6x squared.
6x squared all over
2x cubed minus
2x cubed minus 1. Good. Okay. So then you just go through and clean up each term. This one can stay 1 over x. This one will become 4x over x squared plus 1. And this one will become negative 3x squared over 2x cubed minus 1. I went ahead and simplified the 1/2 times the 6 there, because they're monomials and you can do that. You guys want to get a common denominator? No, you don't have to. Unless the directions specifically say you don't have to get a common denominator for those. Sometimes your book will. So on Couch Chat, you may want to check it a couple of steps ahead, because I don't care at this point. I think you could, right? It would just take a little time. The common denominator would be all 3 of those. So it would just take some time to multiply it all out. That's pretty much as bad as they get. So not too bad. Okay, so for this problem, we have f of x equals the natural log of the absolute value of cosine of x. Do not ask me why they put the absolute value on this one but not on the others. I don't really know. Okay, you're supposed to assume that everything after the log is positive anyway, but for some reason for trig functions, your book will always put those on there. So we take the natural log of cosine of x and we take the derivative of what's after the log. That will become what? What's the derivative of cosine? Negative sign. And divide it by what's after the log. And you don't have to worry about the absolute value. And that just becomes negative tangent of x. So it turns out that the derivative of the natural log of cosine is negative tangent of x. That must mean that the integral of negative tangent of x is equal to the natural log of the absolute value of cosine of x. So that gives you a little idea of where we're headed in section 5.2. So you can go ahead and get your whining out of the way.
Crap.
Yep. Alright, so now let's do something a little different. Let's write the equation of the tangent line to y equals natural log of x squared at the point e comma 2.
Okay.
I know, I'm excited about it.
Okay.
Okay, so to write the equation of a tangent line, we first have to find the slope, right? So that means we have to find the derivative. So the derivative becomes y prime equals, what's the derivative of natural log of x squared? 2x over x squared, which is 2 over x, right? Okay, then I have to find the slope, and I do that by substituting the x value in. So the slope is 2 over x, which is 2 over e. So there's the slope of the tangent line. To find the equation of the tangent line, sometimes I ask you to stop there, and some of you don't, you just keep going. So you need to make sure you do what's asked. I didn't ask you just to find the slope, we want to go all the way and find the equation. So we will use point slope form. And we'll substitute the point in, y minus 2 equals m times x minus e. So we'll distribute. Y minus 2 equals 2 over e times x minus, hey, that's clever. 2e over e just becomes 2, right? Yeah? So what happens when I add the 2? They cancel. So we have y equals 2 over e times x. That's the equation of the tangent line. And what's that used for?
To find that line that goes off the function.
That hits it exactly once, right? Why do we want that?
That's a good question.
No idea.
But if you say to check in your calculator, you put them both in.
That's true, because you can see it only touches it once. Okay, so make sure that you're comfortable finding equations of tangent lines, because I bet you that will be on your quiz. And finally, we would like to find the relative extrema of y equals the natural log of x squared plus 2x plus 3.
This isn't even going to be in a different section. We're just gonna go-
No, we're just going to do it all together now, all the derivatives in their applications, all in one big section. I know, I'm excited about it. So the first thing you have to do is find the derivative and get a least common denominator and set the top and bottom equal to 0 to find your critical numbers. So we'll pause for a second and let you try that. Okay. What did you guys get for the derivative? 2x plus 2 over x squared plus 2x plus 3. Okay. And so for this one, you asked earlier, for this one you would want to factor, because now we're going to set the top and bottom equal to 0. But you don't have to factor, I mean, you could set it equal and then factor. So it really doesn't matter. So to find the critical numbers, we'll say 2x plus 2 equals 0, which means x equals -1. And x squared plus 2x plus 3 equals 0. Does that factor? Doesn't factor. Nothing multiplies to 3 but adds to 2, right? So how do we solve a quadratic equation that doesn't factor? Quadratic formula. So we'll try the quadratic formula. X equals opposite b plus or minus square root of b squared minus 4ac all over 2a. I think I'm allergic to this problem. Hey, good news.
What?
That's imaginary, right?
Yep.
So we can stop. So there is no critical number here. We don't use them if they're imaginary. So that's nice.
So there's only one critical number.
So there's only one critical number, and it occurs at -1. So we'll make a y prime sign line. And then we'll pick a number from over here and from here. And where will we put it? Into the derivative, right. So if I put -2 into the derivative, I get a negative over, hold on, let's see if we can figure it out. I get a negative over negative 2 squared is positive 4.
Positive.
Minus 4 is 0, so positive 3. So it looks like it's decreasing from negative infinity to negative 1, right?
Right.
And it is,
Positive is
From-
2/3.
so it's positive 2/3 if I put 0 in. Yeah. So it's increasing from negative 1 to infinity. And then it asks me to find the relative extrema. So that's going to be a relative min or max? A relative min? Yes? Okay, so it looks like we have a relative minimum at negative 1, comma. How do I find this number?
Okay,
That's the one that goes into the original, right? So if I put negative 1 in, I get 1, 4, 2. I get the natural log of 2. Check it for me. You know I don't multiply and add well. Come on. Negative 1 squared is 1. Minus 2 is negative 1. Plus 3 is 2. So the natural log of 2. There's the relative minimum. And that pretty much wraps up this section. You do have your new syllabus, so it has your assignment on it. So it looks like a lot, so don't panic. You will have the whole time in class next time to work on it.
Oh.